So basically, that's the layer responsible for getting the data into the system and filtering the data in, before. And here we have a, as we call this, a virtual knowledge base. So this is the data store, which is comprising out of free, I'd say, at least logically free data sources, existing data sources of, that customer has at the moment. Our ontologies, so basically RDF and OWL structures, which we are storing here, and data reservoir for doing this this text enrichment and storing all the data which is coming from the media proxy. Then we are doing semantics and text enrichment. So here is the NLP module, which is running on top of the data. Those data are back propagated to the system to be stored in the virtual knowledge base, so that they can be used then for the further processing by reporting dashboards or graph visualization tools. We are also foresee using the use of the discovery tool. Here we are relying on big data discovery to let right people in the organization of the customer to inspect the data and see what's inside the data before we will create the rules, before we will enrich our existing risk assessment component. And so before we are going to make all those changes applied in the runtime, we do this in a, I would say, discovery mode here. So we are looking at the data as they arrive, and we are trying to find out maybe there are some different sources. Maybe we should look at something else. Maybe we should add some metadata. Maybe we should change maybe NLP engine because it's not doing the perfectly right job as we want it to be. So that's more or less the architecture. Unfortunately, we have different requirements from the customers, or maybe fortunately from the architectural point of view, it's always very interesting. But what we found out that some customers are also interested in getting the data from the cloud. So we do have data as a service customer intelligence, as it is called now. This is XSRM listening module, for those who are a little bit familiar with our cloud offering, which provides the interface to collect the data from the internet, let's say, based on predefined topics or specific criteria. So this is something which is also available. Then over the relationship detection, we are again putting the same the data in the same pipeline, and we are doing more or less what I've already explained to you. And now probably the most important thing for you, as we are, as I like to tell few things about how we store the data in graph databases and how we visualize them later on. So this is the version of the demonstrator which is based on semantic graphs. So semantic are RDF graphs in the database. So after the NLP and after storing the data in the big data lake, so in Hadoop cluster, we store the data in RDF data stores, and then after a series of steps, so first of all, through Gina and Sparkle, we were querying the data. Then we're using Viz.js. It's a free library that you can use for visualization, graph visualization purposes, network visualization purposes. So we created our own graph builder on top of this library. At the moment, we are also using Cytoscape. So this is the discussion we had with Jay some few weeks back, and we started to migrate the social intelligence to Cytoscape.js, because there is another version of Cytoscape specifically for the use in the web application. So it's a JavaScript library. So I'll show you this in a moment. And then over REST services, we are exposing this application of logic to, at the moment, Oracle Apex, but this is obviously a place for some fully blown portal solution here. That was one approach, and the second one was based on property graphs. So this was once this was announced by the team a few months back, we decided that it's probably a slightly easier way to represent the data at that point in time where we were. Obviously, spatial and semantic graphs in the database are very powerful and are letting us to also express the knowledge description in forms of ontologies and all this stuff. But we found out that for the moment we also need something a little bit simpler and something which could be used by us specifically here in a big data environment. Because once property graphs were announced, they were announced as a component also of big data appliance. And are based on NoSQL database, which is bundled with a big data appliance. So we ported the solution, and by using Tinkerpop blueprints, which I think we used even today, and again Graph Builder and the same, more or less the same logic, we embedded this time in big data discovery because we had a number of requirements from the customer. Okay, we want to have graphs inside the place where we do the discovery. So we want to see this, how this works, and how those data might be correlated in this way or another. So that's why we embedded this into the discovery tool. And just recently, we have a little bit structured our approach to Graph Spider, as we call this component now, to visualize the graph data. But this is something that may not be that much relevant for you now. Probably it will be a bit clearer when we run the demo. So now let me switch. What you see now is the dashboard with the dummy data loaded. You can zoom in, zoom out. You can try to edit the data. So for this graph, it's obviously to some extent editable. Obviously, it was not our intent to make this to embed those editing capabilities, because we expect this graph to be created automatically. But if someone really wants, can create some sort of additional edges or nodes in the graph. And we used a color-coded approach. So basically, all the nodes has their own meaning and are representing special type of objects. So in the middle, you see now the black ones, which are people, social handles, which are social accounts. For our discussion, let's assume these are social accounts. So all the social identities which this person has in the internet. We can obviously link some internal data sources like police checks and other stuff. And the most interesting probably here is these are the messages and metadata associated to those messages. So for example, if this message was about riots and Canberra, this kind of data would be extracted from this message and would be coded and added to this graph as a metadata. So analyst has a very quick and instant overview of the situation. So assuming that he works on a certain case, he can filter out the graph which is relevant only for him and have all the, I would say, important information available for him for further analysis. Obviously, we can filter this out. So, well, the possibilities are almost endless. So this is something which is based on RDF here. So whatever you can query with RDF and whatever you can transform into some sort of network, we can visualize it here. Yeah, so that was the idea. That's another view. I think a very interesting view. It's this one, where it shows, for example, which people are particularly connected with certain topics of discussions or certain locations. So it may ring a bell for someone, or it may raise a flag to some analyst that something it's bad, it's going to happen somewhere. And yeah, go ahead.
Do you calculate any weights for these keywords, so you know if some of them are more prominent?
At the moment, no, but we have this kind of option both on, obviously, on the data. Well, we do have in the risk assessment component, we take different types of threats and we consider them differently. So we are using different weights at that level. But for the visualization purposes, we are not expressing this here. But this could be easily added. So we can add the property to the nodes and the vertices, for example. Underneath, we do have much more of data than it's visualized here. So we do have types of relationships connecting those people. We do have attributes connected to those. So this is quite complex stuff underneath. And